Acceleration, what you really need to know. Okay, so in everyday life, if I say you're accelerating, you instantly think of speeding up, and usually in a car. So here's where we're going to see this distinction between the words speed and velocity in another context. When we're able to talk about instantaneous velocity, which after Friday's class you should be able to, and how it changes, we do sometimes use the word speed to talk about the magnitude of velocity. Okay, if I have the car and it's in drive and I push the gas pedal, I get faster in what I'm probably going to think of as the positive direction. And obviously I'm accelerating. But if I have the car in reverse and I push the gas pedal, I also get faster, but now it's in what I think of as the negative direction. But that doesn't mean it's not acceleration. If I am getting faster, my speed is changing, my velocity is changing, I am also accelerating. So what is acceleration exactly? It's the rate of change of velocity. Okay? Over a given time interval, the average acceleration is the change in velocity over change in time. I can also have instantaneous acceleration, just like I can have instantaneous velocity. Alright, here's the first tricky word, decelerate. In daily life, we use this to mean slowing down. Now in physics, we also mean that. But really, it's just a special case of acceleration where it's opposing the motion. So whatever direction I'm going, if I'm slowing down, that means I'm accelerating in a direction opposite my velocity. If I'm driving east and I hit the brakes, my deceleration, right, or my acceleration is to the west. All right, so if those don't have to do with positive and negative, how do I figure out if I have positive or negative acceleration? Well, positive acceleration is acceleration that is in a positive direction as defined by the frame of reference. Negative acceleration is acceleration in a negative direction, again, as defined in your frame of reference. So this is where the word speed gets tricky. If I say something is speeding up, I don't care about the direction, right? That's, in daily use, that's me talking about the magnitude of the velocity. And that just means that the magnitude of the velocity is increasing. But depending on which way the object is moving, in my frame of reference, I can have what I consider negative acceleration and still be speeding up. Okay, first example. Car is moving to the left, which we're going to call the negative direction, and speeding up. Okay, so here the velocity is negative, and because the velocity, the magnitude is getting bigger, right? It's speeding up. That means my velocity is getting more and more negative, which means the acceleration is also negative. Okay, example 2. A car is moving to the right, which we're going to call the positive direction, and speeding up. This is kind of the stereotypical first scenario you think of. Okay, if it's to the right, the velocity is positive, and since I'm speeding up, the acceleration is also positive. But that's not positive because it's speeding up. It's because your velocity is getting more and more positive. So your acceleration is positive. Okay, third example. Now the car is moving to the left again and hits the brakes. The car is moving to the left, so the velocity is negative. But it's getting less negative, which is the same as getting more positive. Therefore, the acceleration is positive. Now here's a flow chart that I hope will help. Acceleration is a change in velocity. Now, velocity has two parts, a direction and a magnitude. So technically, a change in either one of those is going to be an acceleration. Now, in this unit, we're only talking one-dimensional motion. So all the motion is going to be in one direction. So unless you turn around, you're not going to get a change in direction. Things won't turn 90 degrees. Okay. That note aside. So if I'm traveling in a straight line, I don't turn around, the magnitude of my velocity stays the same. Nothing's changed. My acceleration is 0. That's the one on the bottom. That one's easy. All right. Now say my velocity changes. Okay. If I am slowing down, the magnitude of my velocity is decreasing. All right. You may call this deceleration. Just bear in mind that deceleration has nothing to do with whether your acceleration is positive or negative in that frame of reference, okay? That's why that first box all the way on the right leads out of the same yes box as the other two that come out of it. They are separate questions to ask yourself, okay? So again, here we see that if it's in a positive direction according to the frame of reference, that change in the velocity, okay, then your acceleration is positive. If your change in velocity is in the negative direction according to the frame of reference, it's negative acceleration. Okay. If my velocity gets more positive or less negative, it is a positive acceleration, and vice versa. Okay, here's the summary. Acceleration is a change in velocity over time. It's the average acceleration if it's over a time interval, or instantaneous if it's at a given moment. Remember, acceleration can be a change in either the magnitude or the direction of the velocity. It can be positive or negative depending on your frame of reference. And deceleration is just a special case of acceleration where the acceleration is in the opposite direction of the velocity. I hope that helps. Please go back and read OpenStax section 2.4. Most of this information is straight out of there, and they have a few extra examples that hopefully will help.